All right, so here's our lesson on absolute value functions and transformations. I just want you to be aware that transformations is something that's going to be super important going forward in this class and all throughout Algebra 2. So today we're going to set a pretty strong foundation for the rest of your high school math career. All right, so absolute value functions are defined by a piecewise function. When we talk about absolute value, it looks like these two bars right here. You can kind of think about it like it being jail. All right, so when we look at absolute value, it is a piecewise function, and remember we look at our domain first. So if I graph these points, and I'll just go ahead and kind of give a rough sketch. If I graph x, that means I start at 0 and I go up 1 over 1. So if you're looking at what I'm doing on the graph, down 1, backwards 1. All right, and then that is for x is greater than or equal to 0. So that means I'm going to have a closed line, and I'm going to go on the positive side, greater than. All right, for my second one, I'm still going to start at 0, but this time I'm going to use a negative slope, which is down 1 to the left 1, up 1, or sorry, down 1 to the right and up 1 to the left. And that is for x values that are less than 0. So that's going to be an open circle, and x values that are less, which means we're going to go this way. So you should notice then that our final graph is this V-shaped graph. Okay, so a few different things that you need to note. The parent function is V-shaped, and the way I always remember that is that it's absolute value, right? You got the V in there. And then there's a few different important points to it. This point down here on the bottom is called the vertex. And then you'll notice that this kind of has a mirroring slope on either side, and we'll talk about that here in a minute. So those are the basics that you need to know for absolute value. Let's look at how the transformations apply. All right, so remember when we talk about linear is like a straight line, right? And we've got this parent function, y equals x, which has a regular slope of 1 and a y-intercept of 0. Remember, we did like 1x plus 0. So when we talk about transformations, we talk about what is different. And we've said the negative reflects, or in your case, you tend to think of it as having a negative slope. The 1/2 is going to make it less steep, right? Because 1/2 is less than 1. So this is going to make it less steep. And then the 3 moved it, it was a shift up 3, right? Because it's going to start at a higher y-intercept. Absolute value is very similar, except now I have a V-shaped graph, and our numbers are going to do very similar things. So the negative is still going to reflect, which means instead of my V opening upwards, my V is going to open down. This 3 is bigger than a slope of 1, so that's going to make it steeper. And now this is what's a little bit different. On linear, we only have the y-intercept that we ever think about, right? We just care about where it's going to hit the y-axis. But in absolute value, we've got this vertex point, and think a y-intercept can only move, if you think about a y-intercept, it can only move up or down. Well, in absolute value, a vertex can move up and down, but it can also move to the left and to the right because it could be anywhere on the graph. It's not stuck to the y-axis, which means, and this is the part that's super important for today, so make sure you're listening. It means that these two things tell me two different pieces of information. All right, so put your hands next to your head and shake your head side to side. All right, thinking about that, anything that is inside, so if we have inside, okay, you're shaking your head left and right, so inside means we move left or right, and you're shaking your head no, which tells us we're going to do the opposite. And we've talked about that before. Anything inside is opposite of the parentheses. And then outside, okay, so outside, nod your head up and down, like you're agreeing to something. Okay, if you think about that, that means you're either moving up or down. And if you're agreeing, it's the same. Okay, so what I mean by that is this +2, It's opposite of what I think. So instead of plus 2, that really means I'm going to move left 2. All right, so that's left 2. And then my plus 4, it's the same, so that's going to be up 4. Okay? That's how the transformations work. So the big things that you need to really have, I mean, you need to have all this written down, but the most important stuff is this information about inside is left and right and opposite. Outside moves it up and down, and it's the same. All right, so let's look at how to graph these. The easiest thing to do, and where we have to start, is that vertex. All right, your vertex is your turning point, and that's where you have to start. So the vertex is going to come from these two shifts. And remember, inside is opposite, outside is the same. So that means my inside vertex, inside opposite, that's going to be -1 or left 1. Outside is the same, +4. All right, so I'm going to start by plotting that point. -1, +4. If it'll let me. There we go. And then the number in the front, remember, that's a slope, so to speak. So the negative is going to make it open down or reflect so that it opens as a downward V. And then the slope is 2. So I'm going to count down 2 to the right 1. Now, this is a V, which means I've got to have a matching point on the other side. So that's also down 2 and to the left 1. We can do that a few more times to get a good V-looking shape. Down 2 and to the left 1. All right, which is going to give me this graph right here. Now, the last part that we need to talk about is the domain and range, which is something we haven't talked about. Well, we talk about it a little bit, but we haven't found it in a while. So domain are our x values. And if you think about it, this is really going to end up affecting the entire x-axis. So our domain, and this is usually true, our domain is always going to be all real numbers. And then our range, this is what's a little bit different. Our range are our y values. So when I pick the range, I want to think about what part of the y values am I using? Well, to me, the highest y value is 4, and then I can use all of these negative y values because it's going down forever. So that means I'm going to have a range of y less than or equal to 4. Now, the quickest way, if I am honest with you and I give you like a little shortcut to think about that, the quickest way to get that is to look at the y value from the vertex and use it. And then this is less than because it's opening down. So if the y value had been 7 and we were doing, the slope was positive in the beginning, then this might be y was greater than or equal to 7. All right, let's do the second one over here real quick. So again, I'm going to start with my vertex, which means my vertex is going to be at inside's opposite, so +2, outside's the same, +3, so 2, 3. This time, it says this should be less steep, so I'm going to make a slope of 1/3. So rise 1, run 3, rise 1, run 3. And remember, we have to have matching points on the other side. And you should notice you've got this really wide V on this side. It's still a V shape, it's just really, really wide. It shouldn't be as steep, right? And so when we go to name our points, we've got domain, always all real numbers. Range, remember the shortcut. Pull the y value from the vertex. So that's y, and then I'm going to use the number 3. And because this is opening up, this time it's going to be greater than or equal to 3. All right, let's look at an example where we actually have to write the equation. And so remember, in those equations, they all appear to be set up the same. There's a number in the front, which is the slope, and then I've got the 2 bars, and then these other 2 pieces of information are from the vertex. So really we need to figure out what's the vertex and what's the slope. So if I look at my graph here, the vertex is this turning point, And my graph is counting by 2, so let's see, that's 1, 2, 1, 2, 3. All right, so my vertex is at 2, 3. And then my slope, if I find all my new points, it looks like that's up 1 over 1. Looks like I have a slope of positive 1. So because my slope is 1, if I go to plug all that information in, I've got a slope of 1. Inside is opposite, so since this is positive 2, I'm going to write x minus 2. And then outside is the same, so plus 3. Which means the simplest way you would see this equation written would be y equals x minus 2, the absolute value, plus 3. Now I will tell you, anytime you write these absolute value bars, you probably either need to make them really bold or just really, really tall, because you need to know that they're absolute value bars and that they aren't ones. All right, there you go. That's all we got for today. We will work on this tomorrow and keep working on piecewise functions tomorrow.